In this section, we're going to look at how to turn a model or a situation into an equation that we can actually use to solve for certain quantities. So in the first scenario we have problems 1 through 4 use the following scenario. A commercial airplane that is 1,500 miles into a 2,500 mile journey is traveling at 450 miles per hour in still air when it picks up a tailwind of 150 miles per hour. The tailwind is going to push them in the same direction. Let H represent the number of hours remaining in the airplane's flight. So my first strategy here is to go through and pick out the key information, so do a little sub search. Commercial airplane that is 1,500 miles into a 2,500 mile journey, traveling at 450 miles per hour in still air, and a tailwind of 150 miles per hour. H represents hours remaining in the airplane's flight. So in question 1, we're asked, how far has the plane traveled thus far? So we want to know how far into the journey is it already? Well, based on what we've underlined and what we've read in the prompt, it looks like the plane is 1,500 miles into the journey already. To find the rate of change of the airplane, we're trying to basically find out what is the speed of the airplane. So miles per hour, how fast is it actually moving? Now, at first glance, it looks like the plane is traveling at 450 miles per hour. However, that is in still air. What they're telling us is that the plane also has a tailwind of 150 miles per hour. Now, tailwind is a wind that is at the back of the plane. It's going to push it forward, make it go faster, versus a headwind, which is at the front of the plane. It's slowing it down. So if we want to find the rate of change of the airplane in this situation, what we need to do is add up our speed in still air and our speed of the tailwind, and that'll give us the speed the plane's actually moving, which in this case is 600 miles per hour. We also want to know what is the total distance of the journey. So how far is this plane supposed to travel? Well, it says right here the 2,500 mile journey. And then which of the following equations best describes the situation? So first let's compare these equations a little bit and see what's different and what's the same. It looks like all of them have 1,500 and 2,500. So those represent the miles. 1,500 is our initial mileage that we've already traveled, and 2,500 is our goal. We'll get to our destination. The other part has to do with the speed times how long we're actually flying. So that's the difference between these two equations, or these four equations, is right in here. Now, one of these just doesn't make any sense at all, and I would say that's option A, because there's no H there. It says plus 690. That just doesn't seem right. 1,500 plus 690 does not equal 2,500. That can never work. There's another choice here that I don't really think fits the problem, and that would be choice D. Because again, that number 690, I'm not really seeing that anywhere in the problem, and I don't know where to get that anywhere from the problem. So I'm between choice B and C. So B says 1,500 miles plus 600H equals 2,500, and C says 1,500 minus 600H equals 2,500. Now, again, we're traveling past that 1,500 mile point that we started, so we know that we're going to add some distance to our 1,500 miles to get 2,500. So because of that, the 600 miles times hours would tell us how many miles that we've, or sorry, 600 miles per hour times hours would tell us how far we've actually traveled. So I think B is the best choice. And if I think about C, and if I actually were to solve this, if I solve for H, I would subtract 1,500 from both sides, then I would divide by negative 600. What I would end up getting is a negative value for the number of hours. And that really doesn't make any sense. We're not really going to travel back in time. We're traveling forward. For problems 5 through 8, you have a different scenario. It says between 2008 and 2012, the revenue obtained from digital music album downloads are in millions of dollars. In the United States, increased by approximately $132 million per year. In 2010, the digital music revenue in the U.S. was approximately $872 million. And if T represents the years since 2008, where 0 less than or equal to t, less than or equal to 4, then we've got some questions to follow that. All right, so again, let's sub-search here. Let's figure out the important information, 2008, 2012. And we're going to call revenue is R in millions of dollars. We know it increased by $132 million per year. 2010 revenue was $872 million. T represents years since 2008, and T is between 0 and 4. So 5 says, what is the rate of change of the revenue obtained from digital music album downloads? And it has to do with this right here, increased by 132 million per year. So that would be our increase, 132 million dollars. Number 6 says, what year corresponds to t equals 0? When did we start measuring the data? It's not 2010. We have a data point there. But it's actually in 2008, because that's when we know it, between 2008 and 2012. So 2008 would be our 0 year. If digital music revenue was $872 million in 2010, we want to know the revenue in 2009 and 2008. So here we have to work backwards using our rate of change. We know in 2010 we had $872 million. In 2009 we should expect $132 million less than that. So I believe that would be $740 million. And we take another step further back to get to 2008. We're going to subtract another 132, and we're going to get $608 million. So which of the following describes the situation? Notice that all of the equations have a 132t. That's represented by a rate of change times the number of years. So I can't eliminate any choices from there. The difference is, what is our initial value? So what is our value at year 0? Well, we know that year 0 is 2008, and we just figured out the value of 2008 was $608 million. So B would be our best choice that models that situation. Let's look at 13 through 16. Use this scenario. The total cost for 7 dance lessons was $82, including the membership fee. The cost for 11 lessons is $122, including the membership fee. We want to find the rate of change of the total cost of dance lessons. What we need to do then is figure out the difference in price from 7 lessons to 11 lessons. So I'm going to set this up as a ordered pair and another ordered pair from the second data point. And I'm going to find the difference in these. So if we find the difference from 82 to 122, just put it here, that's a plus $40. And the difference in our input, which is the number of lessons, has a plus 4. So when we find our rate of change, we're going to end up having $40 for 4 lessons. So our rate of change then is $10 per lesson. Based on our answer to this question, we want to figure out how much did the 7 lessons actually cost, not including the membership fee, just the 7 lessons. And same thing with the 11 lessons. Well, if it's $10 a lesson and we took 7 lessons, it stands to reason then that the 7 lessons cost $70, and that the 11 lessons would be 11 times 10, which would be $110. This is not what we paid. What we paid was more money then. We paid the cost of the lesson plus the membership fee. Well, the membership fee would be the difference between what we actually paid and the cost for the lessons. So we're looking at this particular point here, 7 and 82. We actually only paid $70 for the lessons. We paid an extra $12. And if we did the same with the 11 lessons, we paid $122. We should have paid $110, but we had that membership fee tacked on. So based on that, it looks like the membership fee is the difference between the two. It would be $12. So write an equation for the total cost in terms of the number of lessons, including the membership fee. So our cost will be our membership fee, which is $12, plus the cost per lesson, times the number of lessons. And again, we can pick any point and see if that works, and they do. We could put 7 in for here. 7 times 10 is 70. Add 12, we get 82. We could do 11. 11 times 10 is 110. Add 12, you get 122. So it does work out. The equation holds true.